Imagine this. You're driving down the highway at 100 kilometers per hour when suddenly the engine starts to misfire. It's not a specific sound, not a particular smell. You just feel that something is wrong. The car loses power for no reason. The tachometer jumps around as if possessed, and at the worst possible moment, just when you need to overtake a truck, the engine refuses to respond. You get to the garage, and the mechanic checks everything. Spark plugs are fine, battery is perfect, fuel system is working. Before we get into the symptoms, you need to understand exactly what this sensor is and why it's so important. The crankshaft is probably the most fundamental component of your engine. It's that solid piece of metal, about half a meter long, that's directly connected to the pistons. Its job is to convert the vertical motion of the pistons, that violent up and down movement that happens thousands of times per minute, into rotary motion that ultimately turns the wheels. But here's the critical detail. For the engine to function correctly, the car's computer needs to know exactly, and when I say exactly, I mean with millimeter precision, where each piston is at every fraction of a second. That's where the crankshaft position sensor comes in. These are the symptoms that indicate it's faulty, difficult or impossible engine starting. This is probably the most frustrating and confusing symptom a faulty crankshaft sensor can produce. You turn the key, the starter motor works perfectly. You hear the engine turning over strongly. The battery is fine. Everything sounds normal, but the engine simply won't start. It's as if something fundamental is missing to complete the starting process. And technically, it is missing. It's missing the crankshaft position information. Without that signal, the ECU has no way of knowing the exact moment to open the injectors or when to send voltage to the spark plugs. It may be turning perfectly, but without fuel at the right time and without a spark at the precise moment, combustion simply doesn't occur. What makes this symptom particularly deceptive is that it can be intermittent. Some days the car starts perfectly, the next day it refuses completely. This happens because the sensor may be failing gradually, working when cold and ceasing to work when warm, or vice versa. Cold starts are especially problematic because that's when the engine needs the most precise timing to compensate for the low temperature. I've seen cases where the driver tries to start the car 5 or 6 times without success, gives up, waits 10 minutes, and on the next attempt, the engine starts right up. That erratic pattern is typical of a failing sensor. The common confusion is between the battery and the starter motor, but there's a key difference. If it's the sensor, the engine cranks strongly and at normal speed. It just won't start. If it were the battery, the engine would crank slowly and weakly. Sudden loss of power during acceleration. This symptom is dangerous because it can occur at the most critical moments. Imagine you're accelerating to merge onto a highway or trying to overtake another vehicle. You floor the accelerator, expecting the engine to respond strongly, and suddenly it feels as if someone has cut off the fuel supply for a split second. The engine abruptly loses power. The car stops accelerating, and it may even momentarily decelerate. Then, as suddenly as it happened, the power returns, and the engine responds again. It's a terrifying sensation because you never know when it's going to happen, and it leaves you without confidence in the car. The technical explanation is that the sensor is intermittently sending erroneous signals. During that critical second, the ECU receives completely contradictory data about the engine's actual RPM. It thinks the engine is spinning at one speed when it's actually spinning at another. It then adjusts the fuel injection and spark timing based on incorrect information, resulting in a mixture that is either too lean or too rich precisely when you need maximum power. Some drivers describe it as jerks or hesitations in acceleration, as if the engine were hitting something invisible. This is especially noticeable when trying to overtake on the highway, because you're demanding the engine at its high RPM range, precisely where the sensor's accurate signals are most critical. The real danger is that it can occur in traffic situations where you need immediate power to avoid an accident or complete a maneuver. Cylinder misfires. A misfire occurs when the air-fuel mixture in a cylinder doesn't burn properly or doesn't burn at all. Under normal conditions, each cylinder must fire its spark at a very specific point in the cycle for combustion to generate maximum power. When the crankshaft position sensor starts to fail, it sends incorrect timing information to the ECU. The computer then commands the spark to occur at the wrong time, either too early or too late in the compression cycle. The result is that some cylinders don't burn their mixture efficiently, or don't burn it at all. The symptoms are very noticeable: constant engine vibration, a noticeable loss of smoothness in operation, and a general feeling that something is mechanically wrong. This is especially noticeable when the engine is idling or at low RPMs, where each cylinder misfire feels like a clunk throughout the engine. The characteristic sound is that the engine limps, that irregular rhythm where you can hear that not all the cylinders are working in sync. If you have an OBD2 scanner, you'll see specific trouble codes that begin with P030, followed by the number of the misfiring cylinder, P0301 for cylinder 1, P0302 for cylinder 2, and so on. The confusing thing is that these same codes can appear if you have bad spark plugs or ignition coils. The difference is in the pattern. With faulty spark plugs or coils, the misfires are consistent in the same cylinder. Check engine light illuminated with specific codes. The check engine light is generally the first warning many drivers receive that the crankshaft position sensor is malfunctioning. When this light comes on and you scan the car with an OBD2 reader, very specific codes related to the crankshaft sensor will appear. The most common is P0335, which indicates a sensor circuit malfunction. Basically, the ECU isn't receiving a signal or the signal is too weak. Code P0336 signals a range or performance problem, meaning the sensor is sending a signal but it's outside normal parameters, such as reporting impossible speeds or inconsistent patterns. Codes P0337 and P0338 indicate that the signal is too low or too high, respectively, and P0339 indicates an intermittent signal. Importantly, all these codes begin with P033, which is the specific family of codes for the crankshaft position sensor. It's crucial to scan the car immediately when this light comes on because it provides specific information about what's failing. Many drivers make the mistake of ignoring the check engine light, thinking it will turn off on its own or that it's nothing serious. With intermittent sensors, the light can indeed flicker on and off, tricking the driver into thinking the problem has resolved itself. In reality, the sensor is failing intermittently, and it will only get worse over time. The confusion can arise because other sensors, such as the MAF sensor, oxygen sensor, or NOx sensor, can also trigger the check engine light. But the codes tell you exactly which system is failing. If you see any code P033X, you know for sure it's the crankshaft position sensor. Many auto parts stores offer free code scanning, so there's no excuse for not knowing what's causing the light. Even better, though, is having your own basic OBD2 scanner at home, which you can get for around 20 to 50 euros and allows you to constantly monitor your car's health without relying on anyone else. Sudden engine stalls while driving. This is probably the most terrifying and dangerous symptom a faulty crankshaft sensor can cause. Imagine you're driving normally, perhaps in the city at 50 kilometers per hour, or on the highway at 120, and without any prior warning, the engine simply shuts off. There are no strange sounds, no prior vibrations. It just shuts off as if someone had turned the key. What technically happens is that the sensor stops sending a signal completely for a fraction of a second or more. The ECU, having completely lost the crankshaft position reference, enters protection mode and cuts off both fuel injection and the spark. It's as if the car's brain is saying, "I don't know where the pistons are, so I'd better shut everything down before causing damage." The difference with running out of gas is stark. When you run out of fuel, the engine gradually loses power, sputters, misfires, and finally stalls. With the crankshaft sensor, it's instantaneous and without warning. The extreme danger lies in where this happens. If this happens in heavy city traffic, you immediately lose power steering and assisted braking. The steering wheel becomes incredibly heavy, and you need to press the brake pedal with all your might to stop the car. If it happens on the highway at high speed, the situation is even worse because you have vehicles behind you that don't expect you to stop suddenly. The deceptive thing is that many times the car can restart after waiting a few minutes. The sensor cools down, works temporarily again, and the engine starts as if nothing had happened. This leads many drivers to think it was a random, insignificant failure. But the typical pattern is that it worsens with engine temperature. The hotter the sensor, the more likely it is to fail. This symptom should absolutely not be ignored under any circumstances. It is a serious and potentially fatal accident risk. If your car has stalled even once while driving, you need to diagnose and replace the sensor immediately. Symptom number 3, extremely rough idling. When the car is stopped at a traffic light or parked with the engine running, the idle should be smooth, steady, and almost imperceptible. But when the crankshaft position sensor starts to fail, the idle becomes chaotic. The engine vibrates excessively, the RPMs fluctuate erratically without you touching the accelerator, and you have the constant feeling that the engine is going to stall at any moment. You can see the tachometer oscillating between 600 and 1,200 RPMs uncontrollably, rising and falling in a completely unpredictable pattern. Technically, what's happening is that the ECU is desperately trying to compensate for the bad or intermittent signal it's receiving from the sensor. It constantly adjusts the amount of fuel injected, trying to stabilize the engine, but because the crankshaft position information is incorrect, it can never find the correct balance point. The result is an inconsistent mixture between combustion cycles. One moment some cylinders are receiving too much fuel, the next they're receiving too little. The engine is literally searching for its equilibrium point without being able to find it, like someone trying to maintain balance on an unstable surface. This problem is especially bad after slowing down at a traffic light. You're driving along at a normal speed and everything seems fine, but as soon as you stop the car and the engine drops to idle, the chaos of vibrations and erratic revs begins. Many drivers have to keep their foot lightly on the accelerator to prevent the engine from stalling, which is neither normal nor safe. The difference between this and other problems like a dirty IAC valve or vacuum leaks lies in the pattern and severity. A dirty IAC valve causes a low but generally stable idle. Vacuum leaks cause a high idle, excessive fuel consumption for no apparent reason. Suddenly, you notice you're filling up the tank much more often than before. You haven't changed your driving style. You haven't added any weight to the car. The routes are the same, but the tank is emptying noticeably faster. You check the tire pressure. It's fine. You check the air filter. It's clean. There are no visible fuel leaks. So, what's going on? The explanation lies in how the ECU manages fuel when it receives incorrect information from the crankshaft position sensor. When the signal is erratic or unreliable, the engine computer can't accurately calculate the engine's actual load or exact RPM. To prevent the engine from failing or being damaged, the ECU enters what's called safe mode or emergency mode, where it essentially injects more fuel than necessary. It prefers to operate with a rich mixture, with excess fuel, rather than risk a lean mixture that could cause knocking or overheating. The problem is that this extra fuel isn't generating any additional power. It's simply being wasted. The difference in fuel consumption can be dramatic, between 15 and 20% more than normal. If you normally get 500 kilometers on a tank, now you only get 400. If you used to fill up once a week, now you fill up every 5 days. It's a difference that definitely hits your wallet. This symptom is especially confusing because there are many other things that can cause high fuel consumption. A dirty air filter, clogged injectors, a faulty oxygen sensor, worn spark plugs, a strong, strange smell from the exhaust. This is the symptom that directly involves your nose and is impossible to ignore once you identify it. If you've ever noticed a very strong smell of unburned gasoline coming from your car's exhaust, or worse, that characteristic smell of sulfur or rotten eggs, you have a serious problem that is probably related to the crankshaft position sensor. The technical explanation is that when the sensor is faulty, the spark arrives at the wrong time in the combustion cycle. It can arrive too early, before the piston reaches top dead center, or too late, when the piston is already on its downward stroke. In both cases, the air-fuel mixture doesn't burn completely inside the cylinder. That partially burned or unburned fuel goes directly into the exhaust system. That's where the catalytic converter comes into play. Its job is to clean the exhaust gases, but it's designed to handle small amounts of unburned fuel, not the massive amounts that arrive when combustion is so inefficient. The catalytic converter starts working overtime trying to burn that extra fuel, and in the process, it overheats dramatically. It can reach temperatures of 700 or 800 degrees Celsius, well above its normal operating range. When the catalytic converter overheats in this way, the sulfur compounds naturally present in gasoline are transformed into hydrogen sulfide, which is that unmistakable rotten egg smell. It's the same smell produced by a catalytic converter that is failing or already partially blocked. The exhaust smoke may also be darker than normal, with a grayish or even blackish hue indicating incomplete combustion. This smell and smoke are clear signs that the catalytic converter is being actively damaged, and it's not damage that can be reversed. Once the catalytic converter is damaged by overheating, it needs to be replaced. No amount of cleaning or repair will fix it. We're talking about a bill that can easily exceed €1,500 for many models. All of this can be avoided by acting quickly when the first symptoms of a faulty sensor appear. That's why this smell shouldn't be ignored for even a single day. If you smell gasoline or sulfur coming from the exhaust, the sensor has probably been failing for some time, and the catalytic converter is suffering. Now that you know all the symptoms, you need to know how to test the sensor yourself. You don't need to be a professional mechanic or have expensive tools. With a basic digital multimeter, which you can get for 15 or 20 euros, and a little patience, you can diagnose whether the sensor is dead or failing. First, you need to locate the sensor. Depending on the engine type, it may be in different locations. In front-wheel drive engines, it's usually near the flywheel, at the rear of the engine near the transmission. In longitudinal engines, it may be at the front, near the crankshaft pulley. The best resource is to look online for the service manual for your specific model or watch videos of your particular car. Once you've located it, start with a visual inspection. Disconnect the electrical connector and examine the wires and connector for obvious damage. The wires can break from constant vibration, especially near the sensor where there is more movement. The connector may be corroded from moisture or covered in oil if there are leaks in that area. Many sensor problems are actually wiring issues. If everything looks fine, proceed to test the sensor itself. For two-wire magnetic sensors, completely disconnect the sensor and set your multimeter to the resistance or ohms setting. Place the multimeter probes on the two sensor terminals. The normal reading should be between 200 and 1200 ohms, although this varies by manufacturer. If your multimeter reads infinity, or OL, it means there's an open circuit and the sensor is dead. If it reads 0 or very close to 0, there's an internal short circuit and it's also dead. Once you've done that test, reconnect the sensor and set the multimeter to measure AC voltage. Connect the multimeter probes across the sensor terminals while someone cranks the engine. It doesn't need to start, just crank. A properly functioning magnetic sensor should generate a small AC voltage as the crankshaft rotates, usually between 0.2 and 2 volts. If it doesn't generate anything at all, the sensor is definitely bad. For three-wire or Hall effect sensors, the procedure is different. These sensors need power to operate, so first verify that they are receiving voltage. With the sensor connected and the ignition on but not cranking, measure the voltage between the power wire and ground. You should see 5 or 12 volts depending on the design. Then, while cranking the engine, measure the signal voltage. It should fluctuate consistently between 0 and 5 volts, or between 0 and 12 volts. If you have an OBD2 scanner, now is the perfect time to use it. Connect it, turn on the ignition, and look for live engine data. Specifically, look for the crankshaft RPM. Turn the engine over and see if the scanner displays RPM or shows 0 or erratic values. If your car has a camshaft position sensor, compare both readings. They should be synchronized. Inconsistencies between them indicate a problem with one of the two sensors. Interpreting the results is relatively straightforward. A completely dead sensor is easy to diagnose. It doesn't generate voltage, doesn't show the correct resistance, or the scanner doesn't read RPM. Diagnosing an intermittent sensor that only fails when hot is more difficult. For those cases, you need to test with the engine at operating temperature. If the readings are at the lower or upper limit of the specified range, consider preventative replacement. The cost of a sensor versus the cost of being stranded on the side of the road makes it worthwhile to replace a suspect sensor, even if it's not completely dead. If testing confirms the sensor is faulty, replacing it is generally a straightforward job that most owners can do. The difficulty level ranges from beginner to intermediate, depending on the sensor's location in your specific model. The estimated time is between 15 and 45 minutes. You'll need a basic set of wrenches, possibly screwdrivers, and in some models, Torx or Allen wrenches. The first step is always to disconnect the battery for safety. Next, you need access to the sensor, which may require removing plastic engine covers or, in some models, even jacking up the car. Once you have visual access, carefully disconnect the electrical connector. Don't pull on the wires. Locate the release tab and press it while separating the connector. The sensor is usually held in place by a single 8 or 10 mm bolt. This bolt can become very tight after years of exposure to the engine's extreme heat. If it doesn't loosen easily, apply penetrating oil and wait a few minutes. Don't force it, or you could break the bolt. Once the bolt is removed, carefully pull out the sensor. It may be stuck with accumulated dirt or old sealant. Do not use levers or tools that could damage the mounting area or the hole where the sensor goes. Before installing the new sensor, thoroughly clean the mounting area. Remove all dirt, oil, and debris. A clean surface ensures good electrical and thermal contact for the new sensor. Verify that the new sensor includes its gasket or seal and is correctly positioned. Insert the new sensor into place and begin tightening the bolt by hand first. Here's a critical point. Do not over-tighten. Let's talk about costs. A crankshaft position sensor costs between 40 and 150 euros depending on the make and model of your car. Premium European cars tend to have more expensive sensors than Asian or American ones. Workshop labor can vary between 60 and 250 euros, depending mainly on how accessible the sensor is. In some cars, it's literally a 5-minute job. In others, multiple components need to be removed for access. The typical total workshop cost is between 120 and 400 euros. If you do it yourself, you save at least 60% and in many cases more. In terms of prevention, unfortunately there isn't much preventative maintenance you can do. The sensor simply fails with age, mileage, and constant exposure to heat. What you can do is keep the area clean of oil. Oil leaks that wet the sensor dramatically accelerate its deterioration. You already know the 9 key symptoms of a faulty crankshaft position sensor, from subtle issues like erratic tachometer readings to catastrophic problems like the engine stalling while driving. This small sensor, which most drivers don't even know exists, is absolutely critical for the engine to run. Without it, the computer is completely blind, and the engine simply can't operate. But you know what to do.